Hi, and welcome to my shop for another radio repair journey I'm going to take with this radio. And today is October 4th. So, this is quite a dirty radio. It's really got just tons of dirt all over it. Lots and lots of dirt. Surprisingly, it has a transformer in this little radio. Stewart Warner. Manufactured by Stewart Warner Alamite Corporation of Canada Limited in Belleville, Ontario. So Belleville's a little ways from here. Let's see what we've got happening. We've got something funny here. So this piece sticking out here, that's from a previous tube which had a metal sleeve put over it, and then the sleeve was gripped by this to ground it to the chassis. So this tube is metal to begin with, so it doesn't need this connection, but there's a chance a small wiring change was required in the socket of this tube. And they put this one in. Interesting to find out. Looks like it has all of its tubes. How many tubes? Must be one in back here. Yeah, 1, 2, 3, 4 tubes with a transformer. What else do we see in here? 6x3 rectifier tube, model number R514, 25 or 60 cycle, 115 volts. There's really way in the back there where you can't see. There's some components and stuff sticking out a little bit. On the front, got its knob. Somebody put a red dot on the tuning knob. Why would you ever do that? Look at how much. Watch the pointer. The pointer doesn't move hardly at all. Very sticky. The plastic window here has looks like it's shrunk and pulled away from the outside. It's pulled away anyway. It probably has shrunk a bit. And it looks like somebody's glued it. Maybe that's the original glue, or someone's tried to glue it back and it's just shrunk and pulled away even further. From what I can see of the speaker, it's got a tear in the cone right here. A little hard to see though inside. It looks like it has a tear in the cone. Let's get it out. Oh, this has been sitting somewhere where it's just raining down with dirt onto it. I like them when they start like this though. Because if you can take something in this kind of condition and make it look nice again and make it work nice again, you've really done something. If you take a radio that looks great and is pretty much working, fiddle around with it, you're not adding too much to the whole game here. These don't look like the right original screws, but they might be. So I have another rainy day outside today, and my poor cats have hardly been out for the last couple of days because it's been gray and rainy. Another thing that's a little unusual about this radio, this cord's pretty darn short. Pretty stiff too. So whoever did this one did a super duper job. This is the best plug wire connection I've ever seen done, because they have a knot in here. I've never seen that before. A knot, or they've brought the wires up and then kind of bent them around each other in such a, that's a really interesting pattern in there, in such a way that it's kind of self-locking. And they brought the wire around the outside of the prong and onto the screw, which is the proper way to do it. And so there's still a little bit of loose strands here, which should have been cut away, because those strands can work their way to the edge. And when you grab it with your fat fingers, zingo. But I think we're going to be changing this cord because it's too short, too stiff. I'm sure if I looked at it long enough I'd start seeing cracks in it. But it's good for now. It's good for right now. Screws and goodies over there. Yes. Pull them out. Out he comes. I'll look inside here, see if there's any hints of anything interesting in there. Looks like some wax or something's been dripping there. You can see the plastic has been taped in with masking tape. It looks to me like it's just off center. It's not really shrunk. I should be able to straighten that up a bit. No stickers, no words, no nothing else inside here. No cracks in it. I think this is Big Light. You can see from the bottom, you can see how shiny it now that's what it should look like everywhere. That shiny. But probably even after I clean this, it'll never be that shiny again because the sheen, the hard surface of the material has probably been removed, probably been washed away. Okay, enough of that. Let's put this over here, right out of the way. What about a little radio? A little radio with a transformer. Typically, little radios like this forego the transformer and utilize tubes that can run on very low B+. And you can generate the low B+ easily. You don't need the transformer. This radio is a little older for that, a little too old. There's the crack in the speaker. Yep, it's definitely. There's a hole here. This is a little bit disrupted. So how exactly we got these holes? It's cracked right through there. I don't know how that happened. Got a light bulb here. Filter capacitor looks original here for sure. When we look underneath, we'll find out what else has been done. So we have two very different looking, but I assume are IF transformers here. Very different looking. This one's got capacitors in the top, but this one's got something I'm not familiar with seeing. We've got capacitors to adjust up on the main tuning capacitor. This is the part I could see kind of protruding from the side of the radio. No doubt this is the antenna coil. Can you see there's a gimmick right there? That wire, this one here I'm pointing out, comes up to this wire and just wraps around it. About 10 turns. So that's a type of capacitive coupling or something of that sort that's going on in there. No damage to it though. Looks like nobody's ever done anything to this, but let's find out by looking underneath. Ta-da-ta! Nobody's done anything to this radio. I may have changed the cord at some point because I can see the tape here. So perhaps the cord has been changed out. May not be the case. I guess this is possible. This is original. So these wires are heading up to the switch. So these will be original. So this cord is not original. There's another tape connection down here. So we got 3 tape connections here, 2 at, because of the ends of the wire, and then 1 on the wire coming back from the switch, which is a little unusual, but somehow you have to make a connection from the wires that protrude from the transformer after the transformer is manufactured. There's wires sticking out of it. And then you want to make a connection to the radio. Your choice is find a binding post, a spare post, which is usually what's done. You solder the bolt to the post, or you do the airborne thing with tape. Generally, they don't do this in factories. And I don't think they put such short cords on radios. Although somebody did a lovely job, and I'm so impressed with that. Well, many old capacitors in here. They don't look terrible, but they probably are. 1, 2, 3, 4, 5, 6, 6. Well, that's not that many. Should we try running the radio? If I didn't have a way of restricting power and doing other things to make it safer, I wouldn't. But because I can do this fairly safely. Now this radio's come with a great big long antenna wire. And this sure looks original. It's coming undone though, so I'm going to wind it up. Don't want all this wire spilling out all over the place, or it's going to find its way to somewhere inappropriate. There's a joint right there. Is that what that is? What is that? The cloth covering is just perfectly continuous. How did they do that? What did they do there? You know, there's another spot here and another spot up here. Odd. Is it not? Even the antenna wire can be interesting. There's another joint. So maybe the cat got at this and ate it or something? Maybe a mouse chewed it. Another one. It's not very good. And then a great big section here that's bare. So if this were a 5-tube radio without a power transformer, a hot chassis type radio, that kind of stuff would be a little bit more concerning than maybe. Concerning for getting a shock or having it short to something on your bench when you're not watching. Now, radios have protective ways, you know, to have an antenna wire. Like if a 5-tube radio has an antenna wire coming out of it, it's probably protected with a capacitor to limit the shock you're going to get from it. Volume and switch. Tube's really filthy, filthy, filthy. Well, come on, you filthy radio, are you going to work? Let's find out. So I'm going to, if you haven't watched many of my videos, or this is the first one, I'm going to be powering this up by sending the power through these light bulbs. Actually, just this one here. Just this one. And if there's a short circuit or something really bad in here, it'll try to draw too much power. It'll just simply light up this bulb quite brightly. And that'll tell me the story, and it'll also prevent a full fault current from flowing in the radio and popping my house breaker, which I do not want to be dependent on. So watching the lights, what should happen here is this light should come on a bit, then go down, and then as the tubes warm up, come back on. And it may be so low we can't even see it in here. Let me just douse a little bit of the lighting, make it just a little easier. Let's try this other one. There we go. Okay. This way also we can see the flames and fire much better. So I'm going to turn the switch on here, but there's no power yet. I'm going to power it up from here. My phone is ringing. Okay, a little distraction there with somebody who has a Bing Crosby record player asking me a few questions. So, but I'm back here now. Where were we? We were just about to power them up, I think. So switch is on, volume is down. I was explaining what the light was going to do, and the radio itself is probably going to hum. That's probably all that's going to happen. Here we go. Okay, so there's the tube is lighting. Tubes are lighting. These two anyway. Those are steel. I can't see. There's the buzz. Okay, so we're going to turn it off. So that hum indicates right away that the power supply is not filtering properly, and the AC hum is coming right through the speaker, and that's because of this guy. So first step is unplug them. Next step is to replace this, and then make another attempt. And what is this? This is a yellow, red, green, and black. There's four capacitors in here. It's small, 15, 10, 20. There's three sections, three sections, four wires, three sections, 15, 10, and 20. No, almost certainly one of these is the bypass capacitor for the output tube. Speaker made sound. It's essentially working. That's actually a pretty good show for a first start. So we'll do this guy. Probably leave. This is a pretty packed radio. No, it's not so packed. There's lots of space up in here. It's kind of a very shallow chassis. So what I usually like to do is preserve all these wires and install new replacement capacitors on the same wires up in this area, and not try to install the capacitors all the way up into the circuit. That's a lot more work, a lot more problems. It's much easier to just attach to these wires. They are as stiff as can be. They are totally stiff. Ugh. So that might be a problem. So the black wire shoots right to the chassis here. So I need to get three capacitors, solder them in here. The three leads come out, go to here, based on the size and color. That's the objective. Okay, so I've got three replacement capacitors here. This is a 250 volt one, 20. This is a 10 at 400 volts, and this one's 15 at 400 volts. So I do have the schematic now, and I've taken a look, and the voltage at the power supply is 220 volts. This one's rated to 50. I think that's going to do the trick. So we're going to put these three guys and turn them into one little package here. And then I'm going to solder this negative right up in here where it's going to get some stability. Provide some stability to the this because there's a fair bit of mass there. You know, if you just leave it hanging on wires, maybe it's going to wander around. Maybe. This won't now. Do it something like that. Wow, these wires are so stiff. I have to figure out which one's which too. So let's see, the small guy here. Let's see, let me look on here first. So we have 20. I saw the voltages on this. They're hidden from view. Looks like 300 on the 15. Oh, it's probably this green one. That's probably the low voltage one. Doesn't really matter. I've got high voltage capacitors here anyway. What matters is I get the right one in the right color. So, for instance, the big one is on the green. 15 on the yellow. Which one of these is yellow? So we have yellow. Whoa! Oh, son of a gun. I didn't like that. Okay, stay there. Yellow, red, and green. There's red. Oh my gosh. Yellow and green. Which one of these is green? this tube. This is, I think, pretty sure this is the rectifier tube here. One coming over to the rectifier, and the other maybe green going. So this is probably the output tube here. Yep. So this is probably the bypass. Bypass. Come on, man. Show me a voltage here. Just out of sight. So I'm going to cut these wires maximum length here and take this capacitor out of here so I can see it better. So I can read the voltages on it and be a little more certain about things. These are often put in sort of permanently with rivets. Yeah, it's riveted and soldered here. I don't think I want to try to do anything other than cut it. Just nibble away at this. There. No, not quite. There we go. Out it comes. There's our voltages, 300, 250, and 25. 25 on the green. This looks more green. This looks more yellow. Down here now. Does one of those look more green than the other? Not really. So the green one is the bypass. It would go over to the output tube. And that was this one. And it's going on to pin number, I don't know. So I'm looking for the key on the tube. Can't see it. Pull it out. Without rotating the tube at all. Key is up this way. Let's see if we can see that. Yep, I see the key. So we're interested in, would be pin 8. Or pin 7? 1, 2, 3, 4, 5, 6, 7. Pin 8. Pin 8. Pin 8. Now that's going to be the cathode within the 6K6. 6K6. So I was pin 8. 8 is the cathode. It's got a K there. So that being the cathode, that's definitely the bypass capacitor. So that's definitely the green. And it's the big one. Surprising to me. Just these little capacitors to do the filtering. But a big one, you only need to do a 25 volter. I'm going to be sticking in the big, maybe wasting a big capacitor here. So this is at 25. I've got a lot of 50 volt ones. I'm going to get a 20 at 50 volts. Just looking here for 20 at 50 volts. Who's that? Who's at the door there? Yeah, right here. So I could get a 22 at 50. 2.2. These are bigger. 22 at 50. Grab that. 22 at 50 volts. Oops, that's going to do it. And I won't waste my big guy. Okay, pull out the negative. I don't actually mark it on here. So normally the short guy is the negative. And just slip it back in. Yep. Green capacitor on the green wire. How's that? Okay, first things first here. Okay. And we want to tie that negative. Flip this over. Maybe not flip it over, maybe put it like this. You could have these come down from the top, but it's a lot of problems with all these wires shorting out, so I think I'm going to leave it underneath. Wow, those are stiff. I'm going to be changing these two capacitors tied to the same spot. So I think I don't want to change them out just yet because I want to try playing this with the old capacitors in it just for fun. So I think I can. Slip this up here. Up and behind like that. Now I tend to keep my soldering iron at a fairly low temperature. Not enough heat in it to melt this great big thing. So I'm going to avoid melting this big blob here. I can set this guy right on his head here. Oh, that's good. Oh, that's great. Okay, see beautifully now. Excellent. So we'll solder that in, make it rigid. Okay. Now, so we'll start with this onto the green wire because it's right there. Now, try to trim this. Good luck here. Try to do it the easy way. presto. I'm going to attach it up close to the capacitor body so there's not much wire hanging around here. That's not even the right one, is it? Yeah, that is the right one. That is the right one. That is the right one. Always good to have some self-doubt. Just don't let anybody else know you have it. Further. There. Okay, now 2 more to go. One is this wire going to the rectifier, and the other one is this one. Where is it going? It's going, oh, it's also going to the output tube, but there's a whole pile of stuff attached right here. Why is that? It's going up to the, let's see, 2 wires heading to the light bulb. Wires going up to the, oh my gosh, this is a field coil speaker. I didn't even realize that. This is a field coil speaker. So those wires are going to the field coil from the power supply, and that's why it has small capacitors, because the field coil is a very powerful hum-fighting inductor. Okay, so one wire, this one, is attached to one side of the field coil. The other side of the field coil must be attached. Let's see, it's this yellow and patterned wire. Yellow. Where's the yellow wire go? It disappears. Oh no, there it is. Perfect. Okay, so I don't think there's a problem here. This is the capacitor which goes there. Got that? That's the capacitor that goes there. So I'm going to take a look at the schematic here on my own. No, I'll put it up on the screen. Share the pane here. So from the power supply, we have one that goes to this field coil. That's from C1. So C1 goes to the field coil. C1 is how big? I'm not kind enough to write it right on here. C1. I have to open up another page of this. C1. What? No, I got something wrong here. C1. What? It says it's the, oh, look over here. Hey, just look over here. C1, 15. Perfect. So C1, so the 15 goes on the wire that's going to the so this is the 15. Goes on this red wire. Okay, so the 15 goes on the red wire right here. A bit like that. So this is a great tool for stripping these wires, because these are very hard to strip. The cloth covered wires. Oh man, you know what? I think I can get it in here. So I just put my finger through the speaker. I think we know how the first crack got in there. Now there's another. Don't need much. Okay. I should get rid of this excess wire here. Okay, so this is the big one. Goes here. Okay, and then just by process of elimination, the last one's got to go to this yellow wire. Try to nip it off. Oh, perfect. You're really kind of shattering the rubber insulation inside that wire. It's not so much cutting it. Okay, that's ready to solder. Hey, we're going to listen to this radio in a minute. I'll try the solder's taking here on this old wire. Let's see what we got from that. Not very good. I'm just trying to rough up the wire a bit here by pliering it a little bit. That looks a lot better. Okay, I'll nip off the excess here. Ended up with the wires kind of sticking up, and look, there's wires everywhere, so it doesn't matter. Let me just push this one down a little bit. Everybody's on, nobody's shorted. We're ready. Ready for another shot. Good show. Okay, let's get this out of here. I think we're ready. Ready for another shot. Oh, no, we're not. We gotta put a tube in. Maybe I didn't put my finger through it. Yeah, looks like I did not. It's the same crack there. Okay. Switch is on, volume down, power coming on through the dim bulb here. No action on the light bulb. Tubes are warming up. Some anyway. There comes, oh, that's not very good. What's with that? What's with the hum there? So I'm going to guess the hum is from some other thing going on. And probably as we change more capacitors, we'll find it. Works. Sounds like the capacitor's rubbing there. Yeah, so I think the capacitor's shorted. That's full volume there. Come up. And right there, the short clears. There it's in. There it clears. We're not going to pick up too much up here. Police. So yeah, the police radios a long time ago were just above the AM radio band. And you might think of old movies with police cars with these gigantic whip antennas sticking out the back of them. Yeah, back from these days. Don't think we're going to pick up any police here. And you know, since then they've extended the AM band from 1600 up to 1700. Well, I think the next step is just to replace all those. Well, maybe we should look for the short in the capacitor. Let's just take a look at the situation. See what we're in for here. Okay, so I can look right on the blades. So I can see already this one's bent inwards a little bit, especially the second one is bent also a little bit. See, this one's bent outwards, probably done on purpose. This one looks slightly in. This one looks a little bent here too. Okay, so we're gonna see if we can spot. Oh, it's way down below there. A little hard to see. There's the spot there. It's in this area here. Okay, we'll bring it right up to just where it's about to short. And then I'll use a stick to try to figure out which plate it is. I'm trying to initiate the short. I heard it there. So what I'm moving here is the plate. You can hardly see it way up in here. Does not look bent, but this next plate looks pretty questionable. Looks better actually like that. So now we got to ask ourselves, are the plates over here or plates over here that are touching? This is the oscillator. And this is the RF side. hard to tell with that just going dead. Right on the edge now. Bit sensitive there. So maybe the stator plate has been... Oh, scare the heck out of myself. Don't touch that. Wow, pretty tough to see in here. Can't see past that. I kind of see down here. They look fine. They're pretty protected. These are totally protected. How could the stator plates get bent around in here? They can't. So it's got to be these. These look too close. How did this happen in this radio? This one looks like it's bent over. Just looking for uniform spacing here. So these plates should never be bent. The outside plates are designed to be bent by a technician during the radio's manufacture, the final setup phase. Let's close it right up and see if we can spot, because the short is in place. Maybe I can see it way down there. Way down there. I don't see any shorts. I don't see anything that looks like it's shorted. Just perfect here. I really can't. And they look, from what I can see, they look good there. So the shorting is occurring not at the ends, but somewhere in the middle. Right there. So you can hear the speaker rattling there because of the hole in it. So I just punch another hole in it with this. So the contact's occurring way down in here. So let's start with this plate, pushing it over. Now this will have a tuning effect on the radio for sure. And not necessarily what you want. I mean, this is not a precision radio. Push that a little bit further. And not a radio that you would, try to listen to weak stations or faraway stuff. This is not what this is. That looks very uniform to my eye now. No short. Okay, so that cleared the short in the capacitor. Gets pretty quiet down here. Now, any chance of hearing anything from this antenna? It's my finger touching the bare wires. Okay, we will try that. I'd rather not have both hands touching stuff though. I'd rather hook that up to a more legitimate antenna and not use my finger. Here's a legitimate antenna. Made more legitimate if I go throw a switch. But there's probably enough just in this. Can we get anybody? Hello? 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 Hello. Okay, so I'm going to run it and throw that switch. I'll be gone for just a minute. Not even a minute. I'll be gone for 13.2. Okay, now we have a little better antenna hooked up, I think. Let's bring the ground onto the chassis here. Hey, what happened? Why does that null out the radio entirely? Well, capacitors and alignment and everything. I don't think we're going to hear anybody at this point. It's really tough to tune. Okay, well, I think for today that's pretty good. Tomorrow we'll try to finish it off. Take out the rest of the capacitors, tune the radio up. She should be done. Just like that. Thanks a lot for watching, and have the best day you can.